Hello, and welcome to the next lesson in the financial unit. So we're looking at situations in which you're compounding basically more than once per year. We're calling it other compounding periods. Compounding periods are normally what we've done so far, at least anyways, in the course each year. Before we get to that, let's just look at a question there where we're compounding annually. And so if you had $4,000 invested at 8.3% per year, compounded once per year, sort of the normal way that we've done so far. What would the value of the investment be after 3 years, after 30 years, and how much interest is earned in each? So I encourage you to press pause and try it and see how you're doing. And then come back and see the rest here. Now I just have a solution kind of just worked out that we'll just look through. And so obviously the formula for compound interest is being used here, AP1 plus I, and I've identified the P and the I and the N, and the part A is 3. So we have the principal in is 4,000 right there. The interest rate as a percent in there for I, and of course the 3 in for the N. And so interest gets converted to a decimal, added to the 1. Power of 3 gives some number. I didn't bother writing it in. And then that number times 4,000 gives 5,080, 95.5, and so on. So rounding 5,080, 96. The second one, obviously 30 lines of calculations if we didn't have this special compound equation. Very similar work, just power of 30, giving us this number here in the end, $43,743.52. So I had another one worked out there for 15 years, I guess. And in each case, then you could do the amount of interest you've earned, right? So amount of interest earned would just be the amount you have in the end, take away the amount you started with. I didn't show it as an equation there, but if I did, I might have shown it as A equals principal, amount equals principal plus interest. And so interest equals amount minus principal, which is exactly what this is. Amount minus principal, right? So I equals that stuff. And yeah, that's it. In this case, same thing. So after 3 years, it's $1,000, 1,080. After 30 years, okay. So that's just the work we've done so far. And again, like I said, it's compounding once per year. So other compounding periods, the time after which interest is calculated and added to the principal is going to be called our compounding period. And it's been 1 year so far, right? So in 1 year so far, but not always. Not always the case, right? So we have to be able to deal with that. And so this table shows a lot of the common compounding periods. I added 2 on there that the textbook neglected or didn't include. So annual is the one we're used to, 1 per year. And so of course your interest was just the interest rate. I won't even say anything there yet. And then our compounding periods is just the number of years, right? So where it changes a little bit in the formula, I work backwards and show the annual version. If you're looking at semi-annual, it means twice per year, which means every 6 months or twice per year. So what happens is when you have compounding more than once per year, I'm going to go down here to this part here. So the interest rate when you're compounding more than once per year, what you have to do is you have to divide up that interest rate into equal pieces so that you can apply part of it, in the first half of the year and part of it in the second half of the year, right? So half of it in this case for semi-annual would be half of it in the first half of the year and then the other half in the second half of the year. And what happens is the half the interest rate gets calculated in the first part of the year, first half of the year, and then that gets added into the total. And so then you're calculating the other half of the interest on a larger amount. And so compounding more often based on that thought process leads to more interest. Okay, so what it looks like here though for now is just the interest rate would be divided into 2 equal pieces. This first one here for annual would just be the interest rate. You could think of it as divided by 1, because it gives the right result, but it's really just the interest rate. Same with the annual. The number of years is just the number of years times 1, same thing. But number of years times 2 gives you the number of compounding periods in each year. Okay, so, or not each year, in total, I should say, number of years times 2. Okay, quarterly means every 3 months or every or 4 times per year. So 4 times per year. So we're dividing the interest rate into 4 equal pieces, right? Because there's 4 times per year every 3 months. So number of years would be multiplied by 4. Monthly would be 12 per year, so every month. And so we're dividing it interest into 12 equal pieces. So think of like if it was 12% per year, you'd be applying 1% every month. The interest rate from the 1 each month gets added in, and then that increases your total amount of money that interest is growing on. It leads to more interest because of interest on interest, and so on. The usual stuff, just more often. Daily interest, this is credit cards, 365 equal pieces. So divide the interest rate into 365 pieces and multiply your number of compounding periods, or your number of years, by the 365 to get the number of compounding periods. Other really common ones, you'll see advertisements for cars where your payments are weekly. This is not quite that stuff yet, but then you might be compounding weekly, or your interest might be or might not be compounded weekly. But yeah, so you break the interest into every week, maybe. So you divide an interest rate into 52 equal pieces. And then finally, biweekly is 26 periods per year. A lot of people get this wrong. Note, this is not this one here, biweekly. It's not. Think of like 12 months. So a lot of people make this mistake. I've made the mistake myself, actually. I'll tell you in a minute. 12 months times 4 weeks per month, which that's the problem. It's not actually 4 weeks per month. It's more than that. But a lot of people would think this would be 48. So then 48 divided by 2 would give you 24. It's not 24. Okay? So the number of biweekly periods is actually 26 because of the extra few days each month. 28 days, right, isn't the number of days we have in months. So we have 31, and so that actually adds up to an extra 2 weeks. Kind of hard to believe. And so that interest rate would be divided by 26, and your number of years would be multiplied by 26 to give you the number of compounding periods. So the silly story for me was I was buying a Subaru at Car Canada in Manotick back, this was a long time ago, and I hadn't bought many cars at that point in time, and the payment plan, the payment they told me it was going to be per month was cheaper than I would have thought it'd be, because I did the calculations based on, because I know how to do calculations, right? But I just made the mistake and did the 24 instead of 26. And so the payment they said was cheaper than what I thought it should be. So I was like, basically like, start the car, let's go, it's a good deal. Silly. And then I realized afterwards my mistake. Anyways, it happens. So yeah, here we go. So this thought process just changes this equation a little bit. It's the usual equation, but our interest rate we already dealt with. We said we're just going to divide it by the number of compounding periods per year. And then our number of compounding periods, n needs to be the number of compounding periods now, instead of the number of years. Okay, so now it needs to be the number of compounding periods. So really, it was always the number of compounding periods. Okay, but the number of compounding periods in our simple case was equal to the number of years. So it's really, you got to be careful. You got to have it be the number of actual compounding periods. Number of years times the number of compounding periods per year gives you that. So there's the summary of it. It's not really adding anything. Same interest equation and that. So there's less detail on this summary page, really. So I'll skip that one. So we have a principal of $1,500 invested at a rate of 5% for 4 years. Determine the amount if the interest is compounded annually. And so let's do a normal one. So A equals P1 plus I to the N. And we have our P, we have our I, and we have our N. Instead of listing given and whatnot, that's pretty quick and easy and communicates well anyways. 1,500, 1 plus 5% to the power of 4. It's just the number of compounding periods in 4 years is 4 if you're compounding annually. So this is 1.05 to the power of 4. We'll do that as a number and we'll multiply by 1,500. So 1.05 power of 4 gives 12155. Dot, 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 keeping lots of decimals, times 1,500. Gives us 1,823.26. We get that much money in 4 years if we're compounding annually. What happens if we're compounding semi-annually? So this is just a little bit more often. I feel like maybe I want to do the next one after this is compounding monthly. Let's switch this up actually. I'm going to do this one monthly, just so we can see a bit more of the effect that we get. So we're going to do monthly, so that means we're 1,500. The 1 plus I. So, it's kind of safest to just put this in as 5% divided by 12, right? That way you totally understand like what you're doing, why you're doing it. And then up here you have the 4 years times the 12. You're just very transparent and obvious what you're doing and why. So that gives us 1,500. Now this involves some calculations here, of course. So we have the 5. I may as well do the divide by 100 while we're at it. Right? So there's the 5% as a decimal. Dividing that into 12 equal pieces gives us this number. So 00416 repeated. 00416. So 1.00416 repeated. That shows that I'm keeping lots of decimals. And the 4 times the 12 is 48. So we end up with 1,500 times what here? So that number that I still have in the calculator, we'll add 1 to it and put it to the power of 48. Which is that number, 122,089.5. So 122, I'll just say 122 ... Keeping lots of decimals there, giving a nice accurate result. Way less rounding and source of error here. That number just needs to be multiplied by 1,500. That gives us this number here, 1,831.34. 1,831.34. Okay, so notice that we had 1,823.26. Now we have 31.34. So it's more interest, right? We have the 18.34. Which one's more? Well, this one's more. And it's because of interest being added in earlier. Resulting in more money being invested earlier, right? So resulting in more principal essentially, but more money with interest growing on it. Right, there's more interest on interest. So that's what's going on. Yeah, you could get the number, obviously do the subtraction, right? What's 31.34, take away 23.26, you end up with more money. Okay, we'll get rid of this old version here. I'll actually show it to you quick, I suppose. It was semi-annually, went from 23.26 only to 27.60. Same idea though, right? I just wanted to have more of a difference. And then now let's go to daily. for this one. So compounding daily. So let's do that one. We have a p1 plus I to the n. Now, I in this case is going to be, so we have our 1500 still. I is going to be the 5%, divided into 365 tiny little pieces. And then we're going to operate this, we're 4 years? Yeah, 4 years times 365. So even though you've got a smaller interest rate, that tiny little fraction of a 5%, you're applying it tons of times. So this is 1.00 something. And then up here we have the big power. So 4 times 365 is 1460. And the 5%, decimal 0.05, divide by 365. That number there, 1 point, actually that's a weird thing for us to talk about here. So the number they're giving you is 1.369, so 1.369. I'll just say dot, 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 because we're keeping more decimals. And then this calculator is giving it as times 10 to the negative 4, e to the negative 4. So times 10 to the negative 4. So that's your some calculators probably won't do that. If I did 0.5 divided by 365, just show it. No, that's doing it too. I'm surprised. Not all calculators would. They might just show you a 0.0 or whatever. So what's happening is that decimal place moves 4 spots. 1, 2, 3, 4. There's the new decimal. And so we've got zeros in all of the spaces. So that means we're looking at 1.000 and 1369 ... Okay. So just watch for that. I will screen capture that in for us here. I wonder if I see it says scientific there. I wonder if I can choose a different option. No, it's just the name of the calculator, I think, or standard. Let's try that. 0.5 power of. Oh, it doesn't give us the option for power of. Nope. All right. I just thought I'd try. Yeah, so I guess you just need to know. Press the space bar. Okay. So yeah, you're just going to need to recognize that anyways, really, and it's been taught in previous math classes. So end result here, do I still have that number? No, I don't. So 0.5 power of 365. Actually, that's not what I need to do. Add it before. Decimal 0.5 divided by 365. Add 1 to that. Put that to the power of 1460. Gives us 3117, so 3117, 1500, 3117, ... and we multiply by 1500. Gives us 40. Something seems wrong here. Might have done something wrong. 757. What did I do wrong? Can't be that much. Doesn't make that big of a difference. So I just double check my work here. Bear with me. So we have our decimal 0.5 divide by 365. Get that number there. Then plus the 1. That's the 1.00 number. So it's showing it actually as, that's not doing scientific notation anymore for some reason all of a sudden. I don't think I had that number by accident before. Power of 1460 gives us 1.22. That's the number there. so 1.22, I'll just say ... And that number times 1,500. Definitely start the car and run if they're going to give you that much money. This one's 1,832 and 8 cents. Okay, so $32.08 versus when we compounded monthly, we had 31.34. So we're not investing a large amount of money, so it's not gonna grow to be huge numbers. Okay, so hopefully, if you make a mistake like that in your work, you notice kind of the lack of logic of things too, and make corrections like that. Right, that's an important skill. So sometimes mistakes like that happen, and I don't mind it in teaching because it shows what you need to recognize and do. Sometimes I pretend that I did that on purpose to see if you're paying attention in class, but obviously I don't have anybody putting their hand up and saying, wait a minute. So anyways, therefore in each of these cases, therefore this amount of money, therefore this amount of money, right? Because we're getting real answers that matter to people, how much money they're going to get, and so on. Okay, so there's that monthly one from the last time, but we calculated that first time, so I'll just get to that page. I leave the work in often in case a student needs a copy of a lesson. It's already ready to go with answers. That's why you'll see answer pages that I get rid of from previous times. So here we go. That's the practice questions for that. If you have any questions, let me know. Email or post them in the discussion and all that good stuff. And other than that, thanks for watching.